Welcome to Challenge 16, Estate Risk Analysers. We are a team of 7 with a good mix of skills in Excel, programming, web design and data analysis. This challenge is to use maintenance and incidents records to develop an estate risk profile and predictive model for a given estate. Create an automated risk profile for each site and the estate overall. Produce a view of the estate in terms of the risk of continued operation. Results are presented from a site and PPM perspective. The 3 outputs are an estate model which can be used to give an assessment of the current health of each site, a model which shows the next expected maintenance date, and we've created a script using Python and JavaScript that cleans the input data.
As Paul mentioned, we use JavaScript and Python. I'll be going over the Python aspect. We use Python to clean the 5 Excel files we had, as from this we'd want to use a predictive model. However, from all our cleaning, we got rid of most of the null values. We removed some of the irrelevant stuff, such as cancelled projects. And from this, we gathered that there just wasn't enough data currently to create a predictive model.
I've built a website as a platform for the company to interact with the record. So this is the analytics. So we'll talk about the Power BI later. So this is the history. So all the records in the Excel has turned to CSV and change it to object, so it can be accessed and changed inside this form. And also I create new tab that we can create a new site inside this form and create a new PPM standard here. And also there is an incidents form here, which we can add new incidents and also refer to the old one. And also we have built a sort and filter function here. And for the prediction, because we don't have enough data to generate a result, so probably we will do it if we have better data.
So this is the Power BI report that we've created within the website. We have 5 tabs to show you at the moment. The first one is instance by site. So this visualises how many incidents occurred at each site in the main table here. And the additional tables can show the number of critical, high, medium and low priority incidents at each site. The data can also be filtered by the site priority and whether the incident was service affecting or not, which serves as an indication on the sites which have the greatest risk of equipment failure. In the incident history tab, you can see a time-phased incident rate at each site, and the cards can show how many of these incidents are critical and service affecting. Within the incident criticality tab, this provides detail on how many of the incidents occurred are service affecting and how many of them are critical as a percentage. And you've got that shown with the gauge as well to provide a better visualization of each incident. And you can use this can help to highlight which sites have the greatest amount of attention to reduce the incident rates, most probably by increasing the rates of maintenance. Because of limitations in the data, this is our best attempt at doing a predictive model of when the next inspection is due. This has been done by taking the latest PPM completion date and then adding on the smallest inspection interval, shown by the maximum maintenance frequency, to give an earliest estimate on the next inspection date. And then you can filter this again by each site, which can then give an indication on how long there is between inspections and when the next inspection is due. Lastly, you've got the site health tab, and we've used this to try and work out a instant rate indication, so number of incidents per inspection, to highlight the sites which have the greatest risk of having an incident. And again, you can filter this by whether it's service affecting or not, and also what priority it's at. And this can help tailorize your maintenance on the greatest, the sites which are at greatest risk of having a maintenance issue.
Challenges experienced and future development. In its current state, we use the data set provided in Excel. There was extensive data cleansing required, which meant removing duplicates and addressing NAs and gaps in the data. There was no link between the equipment and the incidents, which was one of the challenges. We used Python for data cleansing and building usable data source, and Power BI is our front end with dashboards, and the website was built using JavaScript. Future prospects. Integration into other reports, e.g. energy usage, capacity planning and risk management would be desirable. With more accurate data on the PPM and sites databases, we would be able to develop a predictive model of where issues are likely to occur in the future. Assign actual location to the site ID to show a visual map of the estate, which allows users to click on location, bring up the relevant data.
So going on to the questions, the first question is what steps can be taken to improve the quality of data in the future? There's a few listed here. I'll go over a few. The first being the PPM register should include separate details of maintenance sites. This allows for all the Excel files to be linked, and it means that we'll be able to analyze data quicker. Another one should be that there's data missing, so this could be for dates within the incident report.
So question 2, how can we build automation into the solution? We like to connect directly into the data source rather than go through Excel, so that updates automatically, which saves having to update it frequently in our Power BI model. And question 3, if we have more development time, what will we do to improve the solution? We'd like to provide analysis for the equipment as well as the sites, because the site is what we focus on the majority of our analysis on in Power BI. And we also like to use the clean data, so using the scripts that we've created, we like to use that in Power BI, because at the moment we've just used the Excel data, which isn't clean, which just makes some issues when doing the forecasting in Power BI.